Hello, everyone. It's 1 p.m. Eastern, and that means it's time to begin our 82nd Weather Talk webinar. We're very warm welcome to you, all of you out there joining us today. I'm your host, meteorologist Henry Regis. Running the technical side of our program is our very own Noah Newman. We're coming to you live from Fort Collins, Colorado, where we are observing the 25th anniversary of the 1997 Fort Collins flood. Yep, that's what started CoCoRaHS 25 years ago on this date. And we've had our share of lightning and rain overnight and this morning. So apropos for this date for sure. Well, for you, those of you who are unable to join us for our live broadcast, we are recording today's talk, and it will be available later this week on our website. All of our Weather Talk webinars are sponsored by the generous donations from listeners just like you. Well, today's webinar, we're going to look at international lightning. As our guest presenter will answer questions like, what nation has the most lightning strokes in the world? Which country has the most lightning per area per year? And many other questions. I think it'll be a very intriguing talk, and looking forward to it. So with us today is Ron Holle from Oro Valley, Arizona. This is Ron's second appearance on our Weather Talk webinar, as he joined us 10 years ago presenting on lightning and its impacts. And so you can go back and listen to that one as well. A lot of good information there. Ron is a fellow with the American Meteorological Society. He's also a meteorological consultant who has worked to help educate the public on issues relating to lightning safety and the demographics of lightning victims and damages. His resume includes time with NOAA Research Laboratories in Norman, Oklahoma, Boulder, Colorado, Coral Gables, Florida, Silver Spring, Maryland, as well as with Vizsla in Tucson, Arizona. As we have said in the past, if you want to know anything about lightning, Ron is the guy to ask. And Ron loves to travel. In fact, he's been to 33 countries, so he'll know a lot about a lot of these countries he's talking about here today. Well, let's give a big CoCoRaHS welcome to Ron Holle. Ron, great to have you with us today. And as we start off today's program, I'll ask you a question that I pose to all of our guests, and that's, how did you become interested in weather, and in your case, particularly lightning?
Thanks, Henry. I grew up in northeastern Indiana in Fort Wayne, and one or two generations removed from the farm. And when our family got together, everybody talked first, how are the crops doing? What's the weather like? What happened yesterday? Why did we see this? And I thought everybody did that, and I never got beyond that stage. Anyway, also another event when I was in grade school, a storm came through Fort Wayne, and I guess I'd say demolished virtually all the trees in our neighborhood. I think now, looking back, we know it was a derecho, but at that time, I don't think anybody really understood what was going on. How did I get into lightning? When I was in Florida, we had a field project out in the Everglades, and quite by chance, the invention of the lightning detection network was underway at the University of Arizona here in Tucson. And they brought some sensors there, and I said, well, that's pretty interesting stuff. And it just grew from there. And we had direction finders 001 and 002 in that project. And so I've been around this since the beginning. That's why I'm here in Tucson.
Wow, that's really neat, Ron. Thanks for sharing with us. It's always neat to hear the different stories, a lot of similar connections with folks as we talk to different people in the meteorology field. Well, I'm going to ask you to take it away with your presentation, and we'll be back when you're finished to take questions from our audience.
All right, thank you. There we go. Okay, I'm a meteorologist here in Tucson. I worked with Vizsla for many years. I completed my time with them recently, but I actually have more projects going on than ever before, so I'm extremely busy. Lightning is fascinating. I think everybody here is probably saying that. As Henry mentioned, I started most of my years in NOAA in Miami, and I took this picture not knowing that lightning was going to become so important. Then I was in Norman before I came here, and this is a long spider flash going across the base of a cloud. Then here in Tucson, this is the view from our house. We have a big mountain range right east of us. It goes up to 9,300 feet, and the storms are over the mountains quite a lot. So anyway, each one of these is different. They're somewhat representative of what things look like in the places I've lived. So let's talk a little bit about lightning. But cloud-to-ground lightning is the one that does damage and unfortunately kills and injures people. Here's a famous picture from Mount San Salvatore in Lugano, Switzerland. I actually went up on this mountain about 5 years ago after a conference we had in Europe. This was taken by a guy in a major field program in Switzerland during the 60s. Here's the cloud-to-ground flash starting out. It started way up in the cloud, coming down. It branches, it has downward leaders. Most of them are not successful, but one of them, for random reasons, decided to come down, and that's the point where it connected. And if you look at this picture from South Africa, we got some years ago, just a wonderful picture. You can see all the branching going on. In this case, it went down more directly, whereas this one branched and went a little bit to the side. So this is what cloud-to-ground lightning looks like. So let's go through some of the topics we have today. I'll go through each one of these, and I have them numbered so I can keep them straight for myself. So let's talk about lightning density compared to lightning fatalities. What nations have the most lightning strokes in the world? Here's a map from Vizsla that has the global lightning data set GLD 360 network operating for the last 5 to 10 years, detecting about 2 billion strokes a year around the world. They're not differentiated in this map between cloud to ground and in cloud. Many or most of them are cloud to ground. So we can see, I put the equator on here, we can see that there's a lot of lightning, particularly in the tropical areas, but also really interesting things going on in the subtropics. So what nations have
can I ask a question on that last slide, real quickly? I noticed Egypt didn't have much lightning. Is that just because there's not many sensors there, or it is not a place where you see much?
No, you don't see much at all. This is the Sahara.
Okay.
And right through here, actually, I've watched the data over the years. Occasionally, storms will occur over this western part of the Sahara, but the eastern part is not. There's no detection problem here. This is real. So during this whole 10 or 5 year period, there just wasn't anything.
Thanks.
So if you go to this website, Interactive Lightning Map, Vizsla.com, you can go in, and each country, this is a new data set, was color coded according to lightning density, that is events per square kilometer. Those are cloud to ground strokes plus in cloud events, just everything. And you can see this ranking. And if you zoom in on this particular website, you can go down to the individual provinces, states, districts, or whatever each country has, and actually see the density by district. It's an amazing map. This was just developed relatively recently. So if you go through those data sets and go just by the raw number, you see that Brazil, which is a large country, has the largest number of detections. US is actually second. The Democratic Republic of the Congo, that one that's in red, is third. And on down through the list. Let me show this on a map. I went through and put a circle over these countries. The number one country in terms of strokes per area, which is what that map was, is Singapore, which is really small. It's just, as you know, it's a small country. Macau is a special administrative district of China, also a small area. Brunei, which I don't think any of us know anything about, is on the island of Borneo up here. Democratic Republic of the Congo here is a large country. And as you go through this list, Cuba is number 8 and El Salvador is number 6. So what do you see in common here? They're pretty much around the equator, within 20 degrees north and south of the equator. And I've looked at the DRC, Democratic Republic of Congo, quite a bit. And what happens there is the storms never end. It goes on 12 months a year. When you go north, you have what we call summer, June, July, August storms. If you go south, it's their winter, December, January, February. Congo just stays, and also Republic of the Congo, which is a different country, to stay with lightning all year round. So here's the numbers that were calculated. 163 strokes per square kilometer. I mean, a square kilometer is not very big. 163 average over a year is really a lot. So what about the US? This, I think many of you have seen this map before. We've had versions of this around for quite a long time. This is cloud to ground flash density. And we can see that Florida has many of the maximum, and also Louisiana coastline, and over in Alabama is also very large. And then a broad swath going north from the Gulf, where the moisture comes up from the south. And also is in the lee of the Rockies. As many of you know, the big storms occur out in this area in the summertime, in the evening, at nighttime. So when you go through and count cloud to ground strokes plus cloud pulses, again, area counts. Texas is a large state and has the most. But so you can see where this comes through. This is flash density now. And so what really matters for getting the largest amount of strokes? Tropical latitudes, hands down, is number one. Number two is the length of the tropical season. I would say the next most important one, these are sort of arbitrary, but it's the way I look at it. The warm oceans nearby. All these Southeast Asian countries are surrounded by very warm equatorial water. Near large mountains, you see a maximum, I'll show this later on, in northeastern Indian subcontinent. The lee of mountains and also large tropical lakes like Lake Maracaibo, Lake Victoria have a large amount of lightning at night, only at night. That's another story. So here's a few cases of flashes here in Arizona. The Grand Canyon is in the northern part of the state. We published a paper a few years ago on lightning in National Park, which is available online if you want to look it up. It's free at this point. And on this, I've superimposed events where people have been killed or injured by lightning at the Grand Canyon over the last 20 years. We can actually see a deficit of lightning down in the canyon. It's a really interesting phenomenon. Not entirely clear exactly what's going on there. There's a lot of ideas and not entirely sure. In general, the storms don't survive when they go over a cliff and there's this deep, warm layer down below. It stops the updrafts. So here in Arizona, I'm down here in Tucson, and we have mountains on virtually every side. So you see that this area down here, we're in the middle of the monsoon season. There's a huge Mexican Mexican monsoon, we call it the Southwest monsoon in the U.S., to the south that spreads storms to the north of us this time of year during July and August. As you go north, the Mogollon Rim here is a large escarpment. And so even though this area here is a very high altitude, typically up 4, 5, 6, 7,000 feet, there's not as much lightning. It's the slope of the terrain that provides the lift for the thunderstorms to be formed, rather than the absolute altitude in many cases. And here's the picture from a study we did in 2017. It's an AMS conference.
Ron, excuse me, if you can speak up a little bit into your microphone, you're dropping off a little bit.
Okay.
Thank you.
Let me crank up a little bit more. Okay, yeah, it's a little low. Sorry. So here's a map of stroke density from the Indian subcontinent. And the Himalayas are right here. And you can see all of the base of the Himalayas, there's a large amount of lightning. And then here's Bangladesh, which has a tremendous amount of lightning for a number of reasons, mainly because there's just incredibly warm water to the south during the pre-monsoon and monsoon. And again, here you can see the coastline of India and Sri Lanka with a lot of lightning where the coast is important. So anyway, it's an interesting situation that we hope to look at in the future, but it has not been studied too much. Okay, let's transition to the next half of the talk of lightning fatalities. Which nation has the most lightning deaths per year? Well, I've gone through all the published literature, some 30 or so papers, and looked at the data for multiple years when it's been published. And this is what I found. India comes up with 1755, and then on down from there. I put an asterisk on this study from Malawi. I looked at it again yesterday. They did a personal survey method in the area where the most lightning is in Malawi, and I don't think it's representative, but that's what they extrapolated out for the whole country from the area they looked at. So anyway, if you look at this, you see that all the rates over 5 deaths per million per year are in Africa. And then there's other countries with the intermediate rates. But unfortunately, we have virtually no data whatsoever over Africa and many of the Southeast Asian countries where we know there's lots of lightning and lightning deaths. So when you add up the documented fatalities from these 30 or so studies, this is what you find, 4,491. These are the countries that have reported something for multiple years in the relatively recent decade or two. My estimate for a number of years has been 24,000 deaths per year for the world. I don't know whether it's too high or too low, but I'm just so suspicious that these missing countries are going to contribute a lot, unfortunately, and I just don't know.
Ron, is there a reason for certain countries having more lightning deaths that you can surmise why that might be?
It's coming up.
Oh, okay.
So the largest death rates, as you see, are all of these countries in Africa, the top 5. I don't trust this Malawi number, but I'm sure it's high. By the way, if you don't know where Eswatini is, it used to be called Swaziland, but it's not been renamed. No, I guess my map hasn't been updated. So anyway, here's the rates. Which U.S. state has the most lightning deaths? If you go back to the last 10 years, Florida has the most. Texas has the second most. And of course, those are highly populated states and also very large areas of states. So these red are the top 10, mostly in the southeastern part of the country, a little bit to the west. Arizona actually, unfortunately, is fairly high. But when you go by per capita divided by the population, you find that there's a big shift to the western states. In other words, there are more deaths per million people in these 1, 2, 3, 4, 5 states in the west than there are a lot of other places. Down here, there's still a lot of lightning. We surmise, don't know, that these high death rates in the western states are because it typically is not raining real hard when there's lightning occurring in, say, Arizona or Colorado or Utah. And so there's a tendency to pay more attention to the rain than to the lightning. And so people are outside when they shouldn't be, or whether it's a low flash rate storm or the end of storm or the beginning of storm. It's a really difficult thing to be sure of, but I think that's a factor. So around the world, what's the reason for these differences? First, you have to have a lot of lightning. If you have a lot more lightning, it does matter. The density of population. Then when you go to the other countries of the world, the quality of the housing and other buildings is really important. We estimate, and I'm doing a lot of work in Africa, estimate that many or most countries of the world of Africa have housing where 80% of the houses are not lightning safe. In the US, it's probably less than 1%. So housing is lightning unsafe, and places where people work are unsafe, and particularly labor-intensive agriculture, where people have a small plot of land. They go out during the day and they work in the farm during the daytime when the crops are growing during the thunderstorm season. Other factors are the awareness of the threat. I think in the US, with the availability of lightning detection data on evening, afternoon weather broadcasts on the Weather Channel, on all sorts of cell phone applications and so on. We know how much lightning there is, and I think the whole awareness level has changed drastically in the last 20 years. The availability of vehicles, there's two safe places from lightning. One is a high quality, well-built building. The other one is a fully enclosed metal top vehicles. In the US, we have access to both of those virtually all of our hours in our day. Other ones are public education. We've done a lot of work in the US and now working around the world on education. And also medical care has certainly helped a good deal. So here's the US number of lightning deaths since 1920. It was over 400 a year in many years back at that time. And we are down now to 11 last year, 11. And that's an amazing accomplishment. So one of the easiest ways to tell what's going on is that we've looked at the percent rural population in the US. In 1900, it was about 60%. Now it's under 20%. And so it's quite rare to have someone involved in agriculture in the US killed or injured by lightning. Typically, they're field workers during large migrant populations that have that, but it's very rare. In other countries, the rural population in countries such as Uganda, where I'm doing work, is still 80%. And so that is a real problem. We've done some studies in other countries. Here's Bangladesh, and here's the fatality rate per million. It's a really interesting figure. These two provinces, I don't know how to pronounce them, have very, very high rates of labor-intensive agriculture. This particular province here, still, I guess it is, has a lot of lightning, but very low fatality rate. I've looked up that area there. It is so unsuited for agriculture that apparently no one is out. Those of you who are meteorologists, right up here is Cherrapunji, India, which has the world's record rainfall from many years ago, 1,001 inches per year. So apparently the agriculture can't even survive in this area here, but all these other provinces are very heavily populated and have a very high agricultural component. We did another study that was published this year in Nepal, and this is the death rate per million people with a lot of data, 10 years of data, unfortunately thousands of fatalities. And it's not where the most lightning is, and it's not where the most people are. And I don't really know exactly what's going on. Our colleagues in Nepal figure it may have something to do with the type of housing and the type of agriculture they're involved in, the time of year. And a new study I'll be presenting in South Africa in October for Jamaica. Kingston is by far the biggest number of, has the largest number of people in Jamaica, but the lightning death and injury cases in the last 16 years are scattered all over the country. They're not there. So these appear to be more, again, agricultural related and also for housing. So I'll finish up with some lightning links that you may want to look at. This is one that I prepared with a co-author for Bicycle a few years ago. It has all the short one-page stories about lightning safety, why it occurs, and so on. Lightning Safety Council is a very big resource for information on lightning. I work a lot with the African Centers for Lightning and Electromagnetics Network, primarily out of Uganda. The National Weather Service has a lot of resources that I had contributed to when I was with NOAA and also with Bicycle. This interactive global map is at this site here. I encourage you to look at it. It's really fun. And then the Bicycle 2021 annual report has all these data for the countries and the states that I showed you earlier, and I participated in preparing that one. And lastly, a shameless plug. About 4 years ago, I co-authored this book with Dr. Marianne Cooper, who's a medical doctor in Chicago. And this was primarily oriented toward developing countries that don't have good knowledge of lightning. So we put a little bit of everything in there: medicine, meteorology, engineering, protection, and so on. And it's been quite popular. And coming soon, Violet Zhang was a student at the University of Arizona here in Tucson. She and I have written a book, which we submitted to Springer Press. I don't know whether it's going to look like this or what, but that's the title of it. And it's in the editing process at Springer right now. And I'll finish with that. Thank you.
Ron, thank you for an excellent presentation. Those books how can people buy those? They go on Amazon or where would they find these titles?
I think if you just type in "reducing lightning injuries worldwide," those 4 words, Springer, it'll come up.
Okay.
And
great.
the unusual thing about this, and I don't understand the marketing process, but we had 20-some chapters in this book, and you can buy each chapter separately.
Oh my!
And our book, our Arizona one, I think we have 7 chapters, and so unfortunately we got carried away. I looked at the contract when I submitted this Arizona book in May, and they said about 160 pages. We had 200. They said about 40 figures, and we had 80. So I don't know why, but they haven't come back to us to say cut it. But we'll see what happens. I don't know.
And all of those links that Ron just showed you, we have those on the WxTalk page for Ron's talk. So if you go to our WxTalk webinar page, you can click on his talk, and they're all listed there. So you can just click on those and then click on the links, and you're there. So we've got those listed. Okay, we'll take some of your questions coming in now. And Nola, are you on the line? And did you have I know you probably have a question before we start out. Maybe not. Maybe he'll come back later.
I can grant Nolan the ability to speak, but he and I can text too if he's got something to.
Yeah, I thought
ask.
He might have had one, but
he hasn't indicated it.
All right. So we've got a couple coming in. What about lightning deaths on golf courses these days? What have you seen there, Ron?
It's down to nearly 0.
Really?
It is not an issue. That was a major issue about 25 years ago, and the effort in the educational area and in the event management issue has made it such that golf courses have information, they have warnings, they have awareness, and it's not an issue. If you look at let me go to this one here. No, this one. If you go to the Lightning Safety Council, John Jinsinius, who was formerly with the National Weather Service, has gone through and defined the occupations and situations where people are injured. 2/3 of the lightning deaths in the U.S. in the last decade are recreation. Things like in the garden, in the backyard, mowing the lawn, everyday things, beaches, water, particularly boats and water and beaches. So golf is almost 0 at this point.
Okay.
And that's a testament to the value of education.
Yeah, I know that mowing the lawn, when I'm always out there, I hear the thunder and I'm like, oh, let me just get it in before that rain comes down, because the grass is going to be hard to mow if it's wet. And so that probably is pretty risky. I'll learn from that. Okay, here's a couple more questions coming in. Gail wants to know, she works at an outdoor museum in Tucson, and the lightning protocol for the staff is to go indoors if lightning is detected 9 miles away. Is that far? Is that too close, or what's the average rule?
Well, I suspect she's at the Desert Museum, which we're a member of. Arizona Desert Museum, a wonderful place. Anyway, I've done a lot of studies over the years with a number of people on, particularly for airports, and it's hard to come up with a magic number. 6 miles is absolutely the shortest range you should use, because lightning does jump around, cloud around lightning does jump around underneath the storm in random ways, and you can't really tell where it's going to be, the next one's going to be. So at 6 miles, you're probably covering 95% of the next flashes. 9 miles is, it's good, but it does increase the area quite a lot. And it's safe. It's always a balance between safety and efficiency. And airports, For example, it's been calculated that when that 6-mile rule is observed, that it costs $5,000 a minute for downtime at an airport, especially at places like Denver, because then that means that the subsequent plane can't go out, another one can't unload, and it cascades through the system. There's a whole lot of studies on that. So safety versus efficiency is a really big issue, and it's a very difficult one.
Okay, thanks. Oh, we're getting a lot of questions in here. So let me go with
That's
those.
why I kept it short.
Yeah, no, that's great. That's great. And we'll try to answer these as they come in. Charles is not familiar with Vissler. Could you explain the organization just briefly?
Yeah, Vissler, it's in Finland. It is a 80-year-old company that was developed in the 30s by Verno Vissler. No, Villo Vissler. His brother was Villo. Anyway, he invented the radio sound. And so the competition before World War II was very intense to build the best radio sound at the best cost, because the weight and so on has to go up in a balloon. And so Vissler has since expanded into every corner of the meteorological instrumentation area, including radars, surface weather stations. A lot of the equipment at airports is Vissler equipment for visibility, precipitation, wind direction and speed. They also do a lot of other things in road weather and so on. And as I mentioned, the lightning detection system was invented at the University of Arizona here in the late 70s. And in around 2002, I believe it was, they recognized that this was the best lightning detection network. And so they bought it, and it's now been part of the Vissler portfolio for about 20 years. So lots of people in Finland. We have a meeting at the conference room in Finland. So that's the way they talk. So anyway.
Ron, is there a website where you can get live lightning data that is not by subscription? Is there anything out there that the Weather Service has put together or anything?
No.
There's not.
It's a commercial product. It costs millions of dollars a year to run the global and the U.S. networks, and so the costs need to be recouped. However, the lightning data from the U.S. National Lightning Detection Network are provided to many or most television stations and many of the apps. So you don't see that it's coming from Vissler, but it is. Sometimes I don't even know where it's coming from.
Okay, thanks. Yeah, I've got a quick question for you. And a friend and I have had a debate where he likes to go out. He says it's just all in cloud lightning. You can tell that there's not going to be any ground strokes, and he'll stay out on his farm or work outside. And I said, one of these days you're going to get a cloud to ground shot out of one of those clouds. And so what's the story with that? Is there storms where it's all in cloud and you don't have to worry about it, or should you be concerned with any storm?
You definitely should be concerned. I don't think there's any storms with more than 5 or 10 in-cloud flashes that don't eventually have a cloud to ground. So that is not a safe approach. When we did our studies of airport warnings, we always include in-cloud lightning as just as valuable for evaluating the threat of lightning as the cloud to ground lightning, because it's really quite random what the cloud decides to do, whether it will put down a cloud to ground or not. So I've mentioned recently that there's a study, if you just look up the longest lightning flash, something like that, there have been some detections now of lightning, ample lightning, like I showed earlier in the talk, that have extended up to 300 to 400 miles. And along that path, they drop a number of cloud to ground flashes along the way. And we have no idea why they did it. Those particular spaces, it's really quite random.
Okay, we had one here from Kara. She was wondering, in Colorado last night, we had some storms where the lightning seemed to be nonstop. I mean, flash, 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 flash every 2 or 3 seconds. why some storms do we see that, and others the occasional flash?
Yeah, I was in Oklahoma before I came here, and I'd never seen storms with virtually continuous lighting like that. And I know they occur in Colorado. I worked in Boulder also. When you look at lightning, you need to think of it as being produced in these layer colder than freezing. And that layer is between -5 and -15 Celsius. All lightning originates at altitudes colder than freezing. So what is most important is that you have an updraft going up through that -5 to -15 Celsius layer. And the faster it goes up and the more mass goes up through that layer, the more lightning you get. So an isolated Florida storm in the afternoon will have a quick updraft. It'll go through that layer. It'll do it for 5 or 10 minutes and may put down 5 or 50 or 500 cloud ground flashes, and it'll be done. In a big organized system like you had last night, I saw it on the satellite last night, there's a lot of processes going up in the sub-freezing layer that are producing large, wide, broad-scale upward motion through that -5 to -15 layer. The cloud processes don't know that that's a lightning production layer. That's just where it decided to do things. And so sometimes it just does its action right in that layer, and that's why you get so much. I mean, we've seen some squall lines or some mesoscale convective systems over the Midwest plains that have produced 200,000 or 300,000 cloud detections in 6 hours.
Are a lot of these that we see that constant flash, are those mostly in cloud, or would you say the majority are that way?
Yeah, probably in cloud. The ratio varies from place to place. In a quick Florida afternoon storm, the in cloud ratio is probably 3 or 5 in clouds to 1 cloud to ground flash. In these big organized systems on the plains, and perhaps in Colorado, it could be 10 or 15 or more in clouds per cloud to ground.
Gotcha. Thank you. So here's what Nancy wants to know: does ball lightning exist? What is that all about? Ball lightning.
Yep.
And is it common?
I was waiting for that question. Yep, apparently so. It's real. I don't believe that there's any credible pictures of it. There are pictures where people have seen things that jiggle the camera and there's something there, but we don't know what it is. There's enough independent stories over the centuries going back into the 1700s of people seeing more or less the same thing. But what it is, I don't know. There's an attempt every year or two by some physicists, particularly in Russia, to say, I've solved the problem of ball lightning in the laboratory, but it doesn't really help with understanding what it is or explaining what it is. So, yeah, if you get a picture of it that's credible, I'd love to see it, but I'm not holding my breath.
Okay.
This is Noah. I want to ask a question on behalf of Nolan, who has texted me, and this is a perfect segue because his question is about myths. Are there any myths, for instance, that have been passed around from generation to generation that are still going around that shouldn't be?
Yeah, that's really a serious question. Lots and lots of them are around in our little booklet here. We go through some of them. One of them is that metal attracts lightning. Metal doesn't attract lightning. Tall, isolated, pointed objects like metal towers attract lightning, but if it was made out of bamboo, it would still attract lightning. So that's one of them. Another one is that what you're wearing, carrying, or holding can make a difference. No. When lightning decides to form, let me go back to this picture here. When this flash came down here, it's coming down at 1/3 the speed of light. It doesn't know what's on the ground. It came down because that's where it had to go. And so what you're wearing or carrying or holding doesn't make any difference. You should be inside of a substantial building like this one or inside of a metal fully enclosed metal top vehicle, which reminds me of another myth I'm sure you're waiting for: rubber tires. That's one we can't kill. I don't know where it started, but it's not true. The reason that you're safe inside of a modern building like this one in South Africa, or inside of your home, is that you're surrounded by essentially a Faraday cage. It's similar to that effect, where when lightning hits the building, it will go around you through the wire, plumbing, and a lot of buildings have metal structural members inside the walls. And so it goes safely in the ground because you have code compliant plumbing and wiring. Now, on that path through the house, it's probably going to do some damage, but you're safe inside. The same thing with the vehicle. When it hits the car, it travels around the outside metal shell and then arcs over to the ground. And what's in contact with the ground? The tires. And when you pass very hot, very intense current through a tire, it's going to blow. So the tires didn't save you. They blew because they were the easiest way to go to the ground. So the rubber tires have nothing to do with safety, and rubber shoes have nothing to do with safety. None of those things matter. You need to go inside of a substantial building or inside of a fully enclosed metal top vehicle. That's the end of the story.
Thanks for that one.
Yeah.
So here's two kind of related. Is it true that one should not be close in a house to a window during a thunderstorm? And then the other question, that was one that came in, and then the other one was that what constitutes poor housing construction for lightning safety? How can I evaluate my house? Edwin asked. So two questions, two different people. One about being near a window. I assume it's a closed window. So I remember as a kid, they'd get in the middle of the room, they would say, stay away from the windows. And I'm just curious.
I'm not real concerned about the windows. The two things that can happen during a thunderstorm, one of them is due to lightning, and that is if the lightning explodes the bark off a tree near your house, it can shatter the window and come through. We've seen bark exploded from trees up to a city block away, and pierced, actually a case in Canada a few years ago, pierced the window of a car, injured somebody inside, I mean, with a large, long, 3-foot long spear of wood. So if you have a tree really close to the house by that window, yeah, that's a danger. The other one is it's a thunderstorm, the wind might shatter the window. I'm not so concerned about it otherwise. I don't like to make a long list of don'ts. Get inside the building and don't worry about the details. Just don't be touching the wiring and plumbing. So in the US, our buildings and houses, our offices are including pretty substantial wiring and plumbing. When a house is hit, the lightning will go through the wiring and through the plumbing, and it may well cause some damage. And in rare cases, it may well start a fire, and it may destroy the house. The only people that have been killed inside of a house in the US in the last 30 years have been elderly, disabled, physically, and disabled mentally. They were unable to get out of the house because of a fire. So everyone else has gotten out. So, I mean, it's compared to being outside of the house in the yard, it's manifestly better. So we have seen some cases in the US of very old houses that have been really seriously damaged. People have been inside but seriously injured. I think because the wiring and plumbing was from the 20s or teens, and probably simply is not adequate to withstand the impact of a lightning flash. Which reminds me, lightning rods. I grew up in the Midwest. They used to look at the lightning rods on the barns. I know Nolan did. Why are they there and why aren't they around? The barns they may have 1 or 2 electric light bulbs in the barn for lighting, or just 1 wire anyway with multiple lights on it. That is nowhere near enough to manage the incoming surge from a lightning flash that comes to the building. So when you put a lightning rod on the top of a building, you have a rod, you have a down conductor, and then a large, substantial pole going into the ground, which takes the surge and goes into the ground safely. It doesn't damage that barn. In our houses, we don't really need that. If you want to have ultimate safety, yes, you can do that. The problem in Africa, where I'm working, is that they have no metal conducting paths of any sort, no wiring, no plumbing, no metal structural members. So when it hits the school or a mud brick house, it has nowhere to go, and the people inside are the back. So think of it that way.
Ron, if you put a lightning rod up on your house, are you kind of asking for it? I mean, is it you're more likely to get hit with lightning with that?
No. When this lightning came down here, we didn't know you had a lightning rod in that house.
Right.
What it does, it takes the lightning that was going to hit that house anyway. It takes it safely into the ground. It didn't attract it.
So you mentioned plumbing. So taking a shower or washing the dishes or anything like that, those activities should cease during a thunderstorm?
Yes, they should. Yeah.
Oh, very good. Here we go. Here's a question from Deborah. She wanted to know, she says, is lightning with no thunder any less dangerous? She says sometimes she sees repeated flashes that light up the sky for a good 10 minutes, but no thunder is heard. She thought that was pretty weird. Is that a dangerous environment? What should she do there?
Well, there is thunder. An event this large, discharge like this through the atmosphere is producing thunder. Now, why you're not hearing it, I don't know. The range of thunder, is about 10 miles, something like that. So if you grow up in the Midwest, you have this old term called heat lightning. And that's lightning that's on the horizon that's too far away to hear the thunder, which is around 10 miles. If it's windy or it's traffic noise, you may only hear thunder 5 miles away or even 2 miles away. So it did occur. Under really specific conditions, it's possible for lightning to apparently happen in the cloud. And if there's an inversion up in the cloud, the sound will propagate more horizontally than vertically, but it was there.
Okay. Bob and Joanne want to know, does lightning strike typically before rain, or can it strike anytime?
I've done some studies over the years, and I found that just in a real broad category, about a third of lightning happens in low rain environments, a third of it during heavy rain, and a third of it after the rain is about over. So it is spread all through the life cycle of a storm. And so one of the problems with lightning safety is that we tend to pay more attention to the rain than the lightning. As in the Western US, I mentioned that the lightning is occurring without a whole lot of heavy rain. Here in Tucson, we have storms where there's virtually no rain whatsoever, and we still have quite a bit of lightning. And unfortunately, those are forest fires.
Donna wants to know, when you see the lightning icons on radar maps, sometimes we'll see a little, I know, radar scope and so forth, they'll put those on there. Is that a measurement of cloud to ground only, or does it pick up cloud to cloud as well on those?
I can't say for sure, but I believe that they're both.
Okay.
So.
Okay. Nancy says 50 years ago, she was a weather observer in the Navy, and they had to be clear when reporting their obs. And she has IC-CC-CG-CA lightning. Is that important now? Is that something that is still done?
Yeah, I remember when I started as an observer in the Weather Bureau back then, it was all those things were out there. We pretty much just divide lightning into cloud to ground, CG, and in cloud, IC, and just leave it at that. I don't know why all that distinguished variations were made. They don't really matter. So in the lightning detection community, it is reduced down to cloud to ground and in cloud, whatever you want to call it. Sometimes cloud pulses, whatever terminology is used.
Okay, Mark has a question here, and he wants to know, looking at the world map there, do you guys monitor lightning over the oceans? So, you know.
Yes, yes. The network, the GLD 360 network is seamless. There's the sensors have extremely long ranges. It's an amazing accomplishment. The sensors that are being used have a 5,000 kilometer range or 3,000 miles. So they're scattered all over the world, and these variations are real.
Okay. Ron, looking at that map in Africa, for instance, right over, is that Libya or Egypt? All of a sudden kind of a lack of lightning right there?
There's no lightning there. Yep. Yeah. Yeah, that area has no lightning. We've looked at it and just don't see any. The storms simply can't form. I read a book. If you want to read a really wild book, it's about a guy who went across Africa on foot and in the Sahara sands, I think it's called. The guy was a nut. Anyway, he walked barefoot across the Sahara with the locals. And he said when they saw a thunderstorm at night in the distance, they went there as fast as they could because there was going to be some green grass there the next day and their camels could eat because it was so rare.
Okay, a couple more questions here and then we'll wrap it up for now. Jim wants to know, should I turn off electronics, TV, computer during a storm? Is that something should I, I remember as kids, my parents would always unplug the television every time the storm would come on. Now we sit and watch the TV actually. So.
Yeah, that's kind of a complicated one. I'm not really into protection too much. I would say that if you have any concerns, we have surge protectors on our computers. Surge protectors need to be, let's say a threshold of, I've been told $75 to $100 for each one. Anything less than that, it's called a terminal strip where you have multiple plugs where you're plugging things in. They have no value. They're all rated according to the level of protection they provide. So if you have, let's say you have a home business and you do a lot of work on your computer, you would absolutely have a surge protector strip or whatever you want to call it attached to that incoming power. It depends where you live. If people live in a more remote area where they're out away from a lot of other people, I've found that I've had calls from people living in say rural Colorado where they have repeated major power problems with blowing things up because when lightning hits the line outside, it may only have one or two places to go, and so it really wallops those locations. But it hits in the middle of a neighborhood, it distributes among a lot more lines, and so the impact is less. And so it is highly variable.
So here's a question: how often, how rare is thunder snow? So a lot of times we'll see lightning during a snowstorm. Is that something that is really rare, or in certain parts of the world, is that common?
Yeah, I did a study on that years ago. Other people have followed up on it in Missouri, University of Missouri. It's not too common. It's not extremely rare. It always happens in the temperature range of the upper 20s to low 30s, and often happens in very high rainfall or snowfall rates, and the temperature is just below freezing at the surface, and it may actually be a warm layer aloft. And so that -5 to -15 Celsius layer is fairly close to the ground with a warm layer underneath it. So that's quite complicated. It's not vertical convection like we were talking about before. It's horizontal. So yeah, I've actually never seen it, but I have studied it, and it's most common, I think, in the Midwest and the plains up into the Great Lakes area. That was what I remember.
I would think that, if you're skiing in the winter or in the spring and you're up on that chairlift and you do see that could be troublesome.
The ski areas, actually, especially in Colorado, have had some incidents in the past, some injuries, and they do shut down the lifts during those situations where it's right near freezing and the wind is blowing hard and it's very, very moist. It is quite a danger.
Thanks. Okay, 2 more questions here. We're going to wrap it up. Mark wants to know, how far away from clouds can lightning strike? So there's that bolt out of the blue that we hear about sometimes, the positive giants and so forth. Could you speak on that?
Yeah, that's one of the difficult things, the question earlier from the lady here in Tucson. I think the furthest we've seen a flash go out sideways from a cloud and then come straight down is about 15 miles from the rain on the ground. That's a long ways. That's a really difficult situation to handle. It's not entirely clear in these cases why it happens. They just do. There are pictures that are reliable of a vertical cloud, and the lightning comes out of that -5 to -15 layer and goes horizontally for 15 miles and then decides to go straight down into ground. That's where the probabilities come in. You just can't anticipate all of those happening, but it is an issue. But the closer you come to the rain shaft or the radar echo, the more likely it is to have the lightning, and the further away you are, the much less likely it is.
Ron, I remember back in 2005, Nolan was working on a manuscript or helping you about lightning strikes, 1800s and so forth, at circuses and farms and so forth. And I think you published a paper on that. Is that available for people to read? And if so, could we list that on our resources?
Yeah, we did a study. We found a book from 1890s, I believe it was, where Kretzer, that's his name, in Illinois, went through and found all the reports of lightning, primarily in the Midwest. And most of them were agricultural, and housing back then had no wiring and plumbing. So people sitting in their living rooms would be there, and lightning would hit the house and just kill everybody inside. And we're seeing this in Africa. We're seeing this in Uganda. That doesn't happen anymore. So we went through and compared that with exactly 100 years later, multiple years of data. Yeah, I'll send you the paper on that.
Great, and we'll list that, folks, on our website when I get that on Ron's website.
Yeah.
Okay, so here we go. Last one. It disappeared on here. So a couple was asking earlier about people that get struck with lightning. So what is the medical stuff? What happens? I mean, does that affect the heart? What happens to you? And then if you survive, is there nerve damage and so forth?
Yeah. Well, Dr. Marianne Cooper here, and she is a medical doctor, and in this book she wrote many chapters about this. She probably knows more about this than anybody in the world. There's only about 2 or 3 other medical doctors who are specialists in lightning injury. It is a neurological situation that is almost entirely due to damages that occur at the time of the event. In the recent years, they've been coming up with the fact that it's relatively similar to PTSD. And so it stops the heart, and how long the heart has stopped determines whether you survive and what the quality of life is after you survive. There is an organization called Lightning Strike and Electric Shock Survivors International, LSESSI. I'll send you that link.
Okay.
And I've been to their meeting a number of times, and there's a whole bunch of people that are in really difficult situations. You don't want to be one of those people. So okay. What happens is, over the long term, the nerve system simply doesn't recover. It's been damaged beyond repair, and it actually deteriorates, and people have a different life. They change personalities. They're unable to do things, and it gets worse. So you don't want to be one of those people.
Well, Ron, thank you for taking the time today to give this fascinating talk. Always great to have you as a guest, and we will post all this information for folks to follow up. Ron's slides are also available if you want to go back and take a look at those as well. I think that that chart where you can go by country and click on them, that probably is very fascinating to look at. We'll hopefully you'll do that too. So Ron, thank you again for being with us today, and we'll be talking to you. We'll probably see you at the AMS meeting in Denver.
I think so. All right. Thank you, everybody, for listening to all my ramblings here. Thank you.
Okay, folks. So as we close out today's program, we want to let you know that information will be coming up shortly on the date of our next Weather Talk webinar, and that we've got one scheduled for looks like October and also November. So check the website or the message of the day for more details as those become available. And then before I forget, when signing off today, please take that short survey that's going to pop up on your screen. Very helpful to us. So until we meet again, stay safe and healthy. This is Henry Regis for the rest of the CoCoRaHS team saying goodbye for now and wishing each of you a good rest of the summer season. Take care.